Hello and welcome to another video lesson with Mr. Roman. Today our lesson is titled Factoring a Difference of Squares. And so here's kind of the big idea is we start with a product of binomials, and if we were to distribute or multiply these, we would get this expression down here, x squared plus 4x minus 16, which we would simplify to x squared minus 16. And we call this a difference of squares. So now what we're going to be looking for is moving from this binomial back to a product of binomials. So this process is called factoring, and we're going to use, obviously, be dividing. So the definition of difference of squares is a squared minus b squared. So notice both terms are squared, and there's a subtraction sign between them. So those are the requirements for difference of squares. Now, to create this product of binomials over here, we have to square root each of these terms. So when we take the square root of a squared, well, square root and squaring are opposite operations. So that's going to become a. And then if we square root the other term, again, square root and squaring are opposite operations. So this becomes b. So now creating the parentheses for the product of binomials, we're going to put the a, the first term, in the first slot. And then we're going to have a plus minus sign here in between. And then we're going to put the b in the second slots. And so this factors into a plus b, a minus b. So let's look at a list of perfect squares here. So I've got numbers 1 through 12. So if we take 1 squared, we get 1. If we take 2 squared, we get 4. If we get 3 squared, we get 6. Or I'm sorry, we get 9. Now notice, squaring is not the same as doubling. So if we take 1 and double it, that would be 2, not 1. Now, 2 happens to be a double and a square for 4. But if we doubled 3, we'd get 6, not 9. So again, we're squaring the number, which means we multiply it by itself. So then if we take 4 squared, we get 16, 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. And then square rooting, remember, is the opposite operation of squaring. So here's kind of a summary of the process that we're going to take. We're going to first look to factor out any GCFs, and then we're going to check for the expression to be these three things. So only 2 terms, a subtraction between the terms, and then the terms are both perfect squares. And if those three are correct, if we have A, B, and C here, then we can square root the terms and create the 2 binomials to factor it. And our prerequisite skill here is factoring out a GCF. So let's start with this. Is there a GCF between these 2 terms? And the answer is no, so we would call this prime. So now we look at, are those 2 terms perfect squares? Yes, they are. So k squared is a perfect square, and 81 is a perfect square, and we have a difference between them, which is subtraction. And so now we're going to square root each of them. So the square root of k squared is k, and the square root of 81 is 9. So now we create our parentheses. So k is going to be in the first part of the parentheses. We're going to put the plus minus sign, and then the 9 is in the second part of the parentheses. So now this is in factored form. K plus 9, k minus 9 are the 2 binomials. Example 2. So again, we look, does this have a GCF? And the answer is no, so it's prime. And then we're going to look at, are these 2 terms perfect squares? Yes, they are. And they have a subtraction sign between them, so that's difference of 2 squares. So we're going to go ahead and square root both terms. Here, the square root of 25n squared is 5n, and the square root of 1 is 1. So creating the binomials, then we put the 5n in the first spots. We have the plus and the minus sign. And then we have the 1 in the second spot. So this is our factored form. 5n plus 1, 5n minus 1. Next example, here we're looking for a GCF, and we do actually have one. So here the GCF is a. So if I factor out that a, I'm left with 9a squared minus 64, which these 2 are perfect squares, and there's a subtraction sign. So this is a difference of 2 squares inside the parentheses. Okay, so we're going to square root each of the 2 terms. So 9a squared is going to square root to be 3a. And then square root of 64 is going to turn into 8. So now we can create the binomials. 3a goes in the first spot, and then the plus minus sign. And then the 8 is going to go in the second spot. And then make sure you have the a, which was the GCF, on the outside. So there's 3 factors here. There's a, 3a plus 8, and then 3a minus 8. Next example. Here, this would be prime because there's no GCF, but this is a sum of perfect squares. Notice this is a plus sign. Both of these are perfect squares, but this is a plus sign, so we can't say it's a difference. So there's really nothing to do factoring-wise here because it doesn't have a GCF and it's not a difference of 2 squares. So we would call this prime. And this example here, again, there's not a GCF between the 2 terms. There is a difference between them, but 24 is not a perfect square. And so we can't do a GCF, and they're not difference of 2 squares, so we just say, again, this is prime. Here we have a subtraction and then 2 perfect squares, so this is going to be a difference of 2 squares. I'm sorry, the GCF, we'll start with the GCF there. GCF is prime. And then we do have a difference of 2 squares, so let's square root each term. So square root of x squared is just x, and then square root of 144y squared is going to be 12y. Then we create the binomials. The x is going to be in the first spot, the plus minus sign, and then the 12y is going to be in the second spot. And then we get this product of binomials in factored form. Next example, again, there's GCF. There's not going to be a GCF here. So we would say that's prime. But we do have a difference of 2 squares. And so we square root each term. So 36x to the 4th square rooted is going to be 6x squared. And 121y to the 6th square rooted is going to be 11y cubed. So now when we create the binomials, this will be the first term. This will be the second term. So first term, we have the plus minus sign, and then the second term. So our factored form, 6x squared plus 11y cubed times 6x squared minus 11y cubed. And this concludes our video lesson.